I'm Anthony.
I'm Cameron. I'm Emily.
We're doing Track A, the Kemper sensor tracker app. Here's our chosen reach feature for our project. It is to pause or resume. This allows us to stop tracking data whenever we want and to continue where we left off. So the first recording didn't show our regime switch very well, but here's another example of a floor change on a test that we did, and it went to floor 2 once we went up the stairs. This is showing
I
the
can't
ThinkSpeak
breathe.
upload, and these are our 8
Oh, that
entries that
was
we
pretty
chose.
funny.
They each contain a different aspect of our data, like latitude,
Very
longitude,
degenerate
and
ways
final
to.
speed,
And you're
as well as
slob.
others. So for our project, we chose the reach feature of the pause and resume. We chose this because it would be useful for mitigating drift from the Dead Reckoning integration when we wanted to take a pause, or when we're walking through an area with poor connectivity, we could try and use it to avoid disconnecting the sensors. When you press the pause button, the status will update to pause, and the distance will stop tracking. So it's useful. As you can see, it will not take any more data as long as it's paused. And then the moment you hit resume, it'll start up again. And here's our app. This has the properties, and then the main function of the app is these update loops. So it'll constantly read the data, put it on the graph, and also will switch out the floors. So here's the startup function. This is just everything initialized on the app. Here's what the start button push is. It'll initialize more stuff, and also it'll start logging. Here's clear button, it removes everything, and then here's the stop button, which ends it. Here's pause, which pauses the loop, and resume, which keeps it going. Half of our script analysis, this is analyze indoor acceleration. This is just meant to estimate position from your acceleration, detect from your phone. This is detect elevator. This detects when you're going up and down an elevator. This detects stairs. This shows when you're walking up a stair. This is detect steps. This shows your steps when you're walking and detects them. And this is analyze reference walk, which is used as a harness function for the final turn-in.
For our results, the app was able to track users both outdoors and indoors. Our return to start error showed noticeable drift because of the small dead reckoning and GPS errors that were gathered over time, especially indoors. For floor detection accuracy, the app in some trials, the floor changed correctly, while in other, the floor number number failed to update during the stair or elevator transitions. And the GPS to indoor switch happened near the Kemper Hall entrance. When the GPS signal became weaker indoors, the switch worked, but sometimes the transition was not perfectly smooth because the GPS signal near the entrance was unstable.
One thing that we learned from this project is that dead reckoning can be significantly improved when combined with GPS data, as periodic GPS updates help correct the accumulated position errors. We also found that developing a reliable dead reckoning system is challenging because phone orientation continuously changes during use. Accurately accounting for pitch, roll, and yaw is critical, as even small orientation errors can lead to large tracking errors over time.